Look, thank you, Ivan. Thank you for your introduction. To everyone, thanks very much for coming. I realise many of you are in the middle of first semester, as I am, and trying to carve out time to attend a presentation like this is difficult. So I value your time and I don't want to waste it. So I hope that I can provide some useful thoughts from at least my perspective. But the reason I'm mainly here is to get your perspectives on my thoughts and how I might modify for the better my engineering teaching and learning at USC. And potentially, as I said, maybe there's things there that we can talk about to improve the teaching that we all do and generate greater outcomes for our students. So I'll share my screen. I apologise, I have got a PowerPoint to share with you, and some of you will have seen a proportion of this when I gave a talk last November. I apologise. I just need to make sure I can maximise this screen. There we go. Okay, hopefully you can all see that. I'm just going to move my video bar. So what I'm talking about today is immersive engineering education, and the question mark there is of course there for a reason, because this is a concept I've been thinking on quite a lot, perhaps not enough, but it's something that especially at the start of each year I think about how I can best do what I do and how we can best do what we do. So I wanted to speak with you about some of my ideas, some of my past practices, some of my envisaged potential future practices, and get your thoughts on that. So to move on, what am I going to talk about today? Briefly, I'll give you my background very briefly, just because it contextualizes where I'm coming from. I will then look at my historical application of the term I use is active learning, and this is the part of the talk that many of you might have seen. I apologise, but it sets the scene for what my thinking was and what or how that evolved. Then I'll briefly discuss reflection I've had on that that prior methodology that I was using, and then essentially put the question out there that do you think there's scope for application of the methods I talk about or introduce in future teaching for our engineers. So very briefly about me. So I'm a late to academia academic. I went straight to the military from high school at age 17, and I spent 20 years in the military, in the Air Force, the Navy and the Army. So for better or worse, almost everything about the way I behave as an instructor / lecturer comes from my military background. And as you'd understand, the military is about getting things done. It's about doing things. So we don't spend a lot of time reading textbooks from front cover to back cover in the military. A lot of the time we do stuff. And one of the things that I did a lot of in the military is a thing called adventurous training. So that term may be familiar to some of you. And what does it mean? It means, well, militaries are designed to fight and hopefully win wars, or at least defend our nation in times of war. When there's no conflicts going on, then how do we best train our troops to operate well under the stresses of war? And we can potentially take them on adventurous training, which is where we put them in extreme environments, such as in this case on the north face of Mount Everest, and we get them to fend for themselves, work in teams, display leadership or learn how to lead and to survive. So we develop skills in them by putting them in stressful situations and then giving them support, and they will evolve as individuals and as teams to better perform in stressful environments in the future. So a large part of what I've done over the last 20, now 30 years is adventurous training. And you'll see that that theme kind of comes out in what I'm about to speak to you about or with you about over the next half hour or so. So as I said at the start, I confess I've plagiarized one of my previous talks from some time ago, and that's deliberate because it sets the scene for how I used to teach, and it still forms the basis for why I do what I do. So I'll quickly run through some facets of this talk which give the historical perspective of how I do what I do. So what did I focus on with that talk? Well, it was what should geotechnical engineering professionals be able to do? How might we as educators, as teachers or facilitators enable that? And then examples of the tools and the ways in which I encourage that or enabled that. I'll give you my brief perspective on assessment. I know some of you have seen that, and then conclude as to whether or not I believe this approach is an effective way to teach engineering students. So of course, before I sorry, I'm just moving my screen around here. Before I worked out what I wanted to do or how I should do it, I needed to work out, well, what was the basis for my envisaged teaching concept? And the first thing I looked at back in the day was the Engineering Australia Professional Engineering Competencies. And many of you have seen these. These evolve slowly over time, of course. I'll speak briefly later on about Engineers Australia's role in what we do. Yes, there's some knowing and understanding. Yes, there's some doing. Yes, there's some being. But I've highlighted the do, of course, because what I'm taking away from this is that most of these 2 to 3 level skills that are required here, they're doing skills. Yes, we need to have some background information, but the way we convey that and obtain that these days is changing. Predominantly, it's what we do with that information that counts, because as engineers, we're not generators of information, we are doers. We build stuff, we construct things, and hopefully we do that well. So from my perspective, and from Engineers Australia's perspective, doing is key to what our engineering students should be able to accomplish. And then I looked at what our institution at the time, USC's graduate attributes were, both in terms of the qualities and the skills that they wanted to engender within our students. And as I've highlighted down the bottom, again, there's more doing than knowing, understanding. So if we go around the circle here, we won't look at each one, but there's a lot of doing there: problem solving, collaboration, communicating, incorporating sustainability. Yes, there's some knowledgeable there, but I argue that these things are perhaps getting less and less important because we have an open source world at our fingertips, and we should be encouraging more things like creative and critical thinking, etc., and the application of technologies and organisation. So as we go around that circle, you can see that most of those attributes are actually doing things. Going a bit more broadly, looking at Bloom, when I was first introduced to being a teacher, to pedagogy, only 10 years or so ago, once I left the military, of course, Bloom was the reference that everyone said, have a look at. And of course, we all understand Bloom's pyramid, moves to higher levels of application and intellectual utilization towards the doing things at the top here. Okay, knowing stuff is a pretty low level requirement. And I don't think we need to be doing too much down there. We should be concentrating on these higher levels of the pyramid. Because I'm today and in this this talk or this assessment was essentially looking at how we might apply that to geotechnical engineering or soil mechanics, etc. One mentor, I suppose, who I look to in that field is a fellow called John Atkinson from University College London. John's written this book, whenever it was 10 years or so ago, Fundamentals of Ground Engineering. And John cuts to the chase in that book, but he says that geotechnical professionals need to do all these things. They need to write reports, measure stuff, do experiments, describe, draw, calculate, etc. They're all doing things, okay? Nowhere in here does John say it's very important for our students to remember stuff or to gain knowledge in X. Yes, they need access to some background knowledge, but they need to be able to do these things. And that's because that's what the profession requires of them. We're not teaching them to do things or encouraging them to do things just because. We're doing that because that's what the profession wants. And if we dig into John's interpretation a bit more, he says, I dislike the word understand as an educational objective because you can't test or measure understanding unless you set a task, a doing task. So the question is, what should engineers be able to do? So after doing that, that lit review to some extent, that appraisal of what the world says engineers should be able to do and how might we teach it, this was my conclusion, that when I was developing my courses at USC in soil mechanics and in geotechnical engineering, essentially I wanted to do things and only a couple of things per week. Why? Because if we get them to do too much, then they won't gain competence in those skills. So we're better off limiting the skills we want and making sure that the key skills that industry needs. And they need to do that, certainly, yes, upon a base of desired knowledge, but we don't need them to memorize this stuff because it's available at their fingertips these days when perhaps in the past it wasn't. Another thing that I say to all of my students, and I've been saying this over the last few weeks with Introduction to Engineering, all our first year engineers, is that universities no longer have the requirement to fill people's heads with information. Back in the old day, that might have been the role of lecturers when they were the only ones who had access to the information, and thus it was their role to convey that information. But in this day and age, when students have all that information at their fingertips or their thumbs, then we're wasting our time and their time by pouring information down their throats. And again, it's the doing things that I believe that we should be emphasising. In the last few weeks with Eng 101, I've been speaking about critical thinking, and I posed to my students this article by the Harvard Business Review. It's a couple of years old now, but it's still very relevant, and it says the 3 things that CEOs lack with regards to critical thinking. The third one is diversity of thought. So that means that CEOs need to do far more of what we have on the right here, divergent thinking, which is creating ideas. The problem is in our engineering courses, we tend to give our students all of these facts, and then we say, take these facts to solve this problem, to converge to a solution. What we fail to do is recognise that we need to encourage divergent thinking to generate a greater pool of ideas, which they then may be able to draw upon to come up with a better solution to whatever problem there is. So I've had broader discussions over the last month with my students, and the fact that most engineering degrees in Australia and probably the world, to my mind, unfortunately, are forcing us to think convergently, to take known facts and apply them. I use the example of someone like Elon Musk. Whether you love him or hate him, he's essentially thrown away this model. He spent his time coming up with divergent ideas that no one else has ever thought of, and then he's getting the, perhaps the best engineers to apply them. But he's coming up with all of these ideas I'm not sure if we're actually generating through the way that we teach engineering at the moment. That's a bit of an aside. We could talk about that for a long time, I think, but it's quite interesting that it's come up repeatedly in my discussions with my first year students over the last month. So back to how I might practice active learning in the classroom and hopefully outside the classroom. Again, building on my adventurous training background, you can't just throw someone in a situation without contextualising that situation. So we need to give our students some pre-reading or some background. We then need to discuss and further contextualise that theory that we might have discussed. And in the old days, we might have called these lectures, but I try not to lecture anymore, and I have mini discussion seminars, etc. Then we do things in the lab, and then we might apply or analyse or utilise that material in a tutorial or similar environment to validate understanding and application of whatever the concept is that we're trying to get through that week. And remember, hopefully I'm only addressing 1 or 2 concepts that week so that we get them nailed, rather than exposing them to lots of concepts, but we never quite close the loop, and students are never quite sure how they might apply or correctly utilise that skill. So looking at each of these individually very briefly, do we need a foundation of knowledge? Yes, I'm sure we do. And do textbooks still provide that? Well, certainly they do. So in the past, I relied on textbooks such as this one by Siva Coogan and Das, because it's quite a practical approach to geotechnical engineering. Increasingly though, again, this is my choice, my opinion, I believe we're beyond textbooks. The internet is there, open source information is there, and I think that constraining students to look at one particular body of information is limiting their ability to gain potential solutions to problems globally, which they can do in the blink of an eye from their fingertips. With regards to lectures, again, I don't tend to lecture, as I said, but I do tend to have small seminars on a weekly basis. And in some of my courses, particularly advanced soil mechanics, I pose the students questions, and they go away for the week and they come back to answer those questions, and we either utilise the tools like Padlet, but increasingly I just use an open forum situation where I'll invite either by volunteering or randomly one of the 4th year or 3rd year students to essentially run the tube, come to the board, explain their solution to the problem, whatever that might be, draw other examples or opinions from the audience, draw opinions from me, and as a collective group we work together to think what might be a sensible way to approach a solution to a particular problem, and then we might look to some references, hopefully contemporary and historical, to suggest how others may do that. But I'm trying again to encourage divergent thought rather than just their blind application of a way of solving something, because all I'm doing is teaching them to be technicians. I'm not teaching them to think about how to solve a problem. Of course, active learning or active doing, we need to do stuff. So every week in Eng 312 saw mechanics and Eng 432 advanced saw mechanics, we're in the lab. We're either in the lab or in the field, and we're doing something. So we jump through the hoops of the standard saw mechanics tests, and we do, sometimes we have tutorials in that space, but most of the time I'm trying to get rid of the transfer of knowledge and make sure that I'm getting students' hands dirty on a week-to-week basis. So as I said, every week has a lab, because I think hands-on utilisation of the equipment, knowing why we do it, etc., is essential for their learning and application of the skills that we're trying to develop in them. And which leads into application. Okay, we start with the base of knowledge through the pre-reading. We discuss it in a lecture/seminar series. We then get our hands dirty, so we understand how we gather that information. And then, of course, the last step is, what's the point? Why have we done all that? Well, we've done it to apply it in a particular role or a particular way. So we're essentially closing the loop from a knowledge base to a discussion to contextualize it, to a getting your hands dirty utilisation, to then an application. So I think those 4 steps used together can be very useful when applied to 1 or 2 concepts every week throughout a semester. And of course, like many of you, I was encouraged when I went to the seminar that Ivan ran in November last year that we all trudge along in isolation to some extent, doing what we do, thinking it's a good way to do it. Occasionally we get involved with A squared, E squared conferences, etc. But it was encouraging to see that many of you at Griffith and beyond are utilising tools like this, hands-on tools in the workshop. So I might use dowel rods to look at particle behaviour in 2D. We might use pressure sensors to look at how a stress is distributed through a soil mass depending on the shape or weight of an object that we put on top of it. Again, we might use a fish tank with sand to look at piled foundations or shallow foundations. And also, like many of you, we have flow net apparatus. This one's getting a bit long in the tooth, actually. We need to replace it, but we have apparatus like this that we can use to convey the movement of water in soil, etc., etc. And of course, because I come from an outdoors environmental background with the military and adventure training, I'm very fortunate on the Sunshine Coast that we have one of the greatest soil mechanics labs on our doorstep. And this is something that, to be honest, I should have utilised far more. And I'm quite happy to be reprimanded for not using this. Ever since I started at USC, I've been planning to run soil mechanics courses at the beach. An intensive 1 or 2 day course where we spend the day there. We could even camp at the beach. We could have barbecues, and we run through all the labs with lab equipment that we might bring to the beach, and we discuss all the concepts, because we can probably discuss most of our soil mechanics concepts by spending a day or 2 at the beach. The mechanics of doing it have been realised. I know how we could do it, but the problem is, as many of you understand, is timetabling. It's very difficult to run intensive courses amidst a university structure that relies on 2 or 3, 12, 13-week semesters through the year. So unless that's thrown up in the air and we start again, unfortunately, with students working and other commitments, etc., it's very difficult to bring students to an intensive lab for a couple of days. And this is something I'll highlight again shortly, because it's something I hope we can eventually overcome. In my other course at USC, again, some of you have seen this, I apologise, 432, which is Advanced Soil Mechanics or Geotechnical Engineering. It's essentially a project-based course where the students do lots of things. They do a risk assessment, they liaise with facilities about what they're going to do, they prepare and manage a budget, they manage their project, they design a wall, they test the site, the soil mechanics or soil material properties on the site, they construct a wall, they do laboratory testing of samples they take from the site, they model the wall using software, they then test the wall empirically for real, and they give me their pseudo-client briefings on how they're going. So, if you look at the 10 or 12 steps there, essentially it is a mini civil engineering project that I'm forcing them to grapple with. And assessment, of course, is tied in with that process throughout the semester. To zoom in on that a little bit briefly, yes, they have to design a wall using appropriate software, etc., etc., and again using appropriate design principles and Australian standards, etc., for designing and retaining walls. Then, as I said, we don't just make up soil properties. We go out to the site. We're fortunate to have a site on the USC campus where we take samples and we do shear box tests, and we do drop cone penetrometers, and we do liquid limits, and we do plastic limits, and all sorts of things. So I'm forcing them to get real data from the soil that they acquire from the site. Every year we bring a CPT truck in, so we get CPT data, which they can then utilise to validate strength characteristics, etc., from their lab testing, and they also use that to assess liquefaction potential on the site, which, of course, with large amounts of water that we've had over the last few days, potentially in low-lying, poorly drained sites, if we get vibration nearby due to a highway or railway or something, then potential liquefaction is an issue they need to think about. So I certainly encourage them to do that. Modelling, I realise that I'm not a modeller, but our students need to be abreast of at least some of the ways that they can model the behaviour of soils. So they typically just use slope W as an introduction to how they might represent and then model behaviour of that retaining wall that they construct, and how it might fail, etc. And in this case, again, we're very fortunate. We've got some space at USC. And I mentioned to some of you in November, we built this wall, which you'll see shortly, about 5 years ago. And the original plan was that every year we would build the wall, test the wall, destruct the wall, and then rebuild it again. But the reality is that the man hours required to build and construct the wall, we were very fortunate to get Shadforth, the local contractor, in to help us build this in the first place. But it's unrealistic to destroy the wall every year and then rebuild it. But fortunately, this first year, which was 5-6 years ago now, we did have the equipment, and the students here got training in the equipment, and then they built up appropriate layers, compacted, etc. And they did the doing of the building of the wall after they designed it. There's our final wall. We had drainage installed on one side and non-drainage installed on the other, and the plan was to saturate the wall with water and then attempt to fail it and see what implications there was for lack of drainage behind a wall and things like that. So it started out with some grand expectations that, unfortunately, due to the logistical realities, we've had to constrain a bit over the last few years. But the wall's still there. We hit it with a whippersnipper and a mower every now and again. It's been pockholed by many years of soil sampling these days, but it's still used as a means to apply engineering, site investigation and assessment techniques in the real world, at least on a limited basis each semester. Briefly, one slide on assessment. Many of you have heard me say this. I don't believe in exams. Why? Because they don't exist in the real world. And yes, they might be useful to assess knowledge, but I made the point earlier that in our open source world where knowledge is at your fingertips, then perhaps assessing it is not really relevant. So that's why every assessment essentially involves a task that they might be called upon to do in the real world. So not only are we getting them to practice skills that they'll need as a professional engineer, but we're also carefully giving them useful feedback and assessment on how they might be able to improve that, which gives them greater chance of getting the job they want, etc., etc. So we're supporting them in a pastoral care way as well as in a professional way, which I think is extremely important in our roles as teachers at university. USC has a newish 3D visualization cave. I know QUT has one also, and I'm not sure if Griffith has, but I'm sure you're aware of these sort of rooms where you can put on glasses and get a 3D immersive experience. Again, I'm sure there is value in these facilities, but because of my hands-on active learning background, it's not something that I necessarily utilise in my courses. I tend to rely on getting them outside doing things, as I say there, because it's only by doing that understanding can be achieved and demonstrated in an assessment point of view. Okay, and the big question, of course, Adrian McCallum from USC has been waffling on about his active learning techniques. Do they work? Well, at least back in the early days here, yes, they were working, they do work. Have those graphs stayed the same over the last few years? No, they haven't, but that's probably to some extent due to me becoming stale with regards to delivering the content rather than the techniques not being utilised. So, of course, we'd all understand that we need to rejuvenate our courses and potentially ourselves to make sure we're giving the best of us to support our students. But certainly the students do like getting out of the classroom and getting their hands dirty across both my courses, which is terrific. So in conclusion to that talk, which is essentially a historical perspective of how I used to teach and how I still do, but I'm thinking on evolving, I would preload them through pre-reading, etc. We would discuss 1 or 2 concepts for the week only 1 or 2, and we would do that in a flipped manner where questions would be posed and then we would discuss in a mini seminar. Then they would do something either in the lab or in the field. And then, of course, there's no point if we don't close the loop, which is, okay, what's the point of that? How do we apply it? Let's reflect upon how we might utilize that in the real world. And then the cycle, of course, starts again as the new weekly themes change. And then ideally, if there's desired university attributes, then they should be reflected in the program attributes, the course, the teaching that we do, the assessment that we utilize, and the rubrics that we use to mark, so that there's consistency and that we're not, we're just not getting inconsistency from what students expect and what we're delivering for them. Okay, so that was a long historical perspective. But then, look, I'm, getting along in life, and I spend perhaps too much time these days thinking on how I can best spend the rest of my time on the planet. So last year on LinkedIn, I published this short piece called Postulations on Empowering and Enabling People to Lead Fulfilling Lives. And essentially it was my brief, very brief manifesto on, how I think we can best do that. And that includes my students at USC. So to be clear, I teach both science and engineering at USC because my first degree was science before I became an engineer. So at the end of last year, I was envisaging a company, actually, a business outside of the university that would enable empowering journeys of education and discovery that would develop mind, body, and soul. So it would be based on adventure travel. It would incorporate aspects of organizations like Outward Bound, which do things along the adventurous training model, where they take people into the field and they give them problems that they then need to solve either individually as a team. So it would take those 2 existing facets, but it would introduce a third facet of delivering Texas certified university education as well. So it'd be drawing from adventure travel, adventure training essentially, and university doctrine, or the way we teach tertiary level teaching. The tool, the mechanism by which they would be brought together would be through these journeys, and the outcomes or the deliverables would be an immersive expedition experience, because they're out in the world carrying a pack, sharing a harsh physical environment with them by themselves and with others. They're getting an opportunity for self-discovery to think about, well, actually, who am I and what do I want to do? Is it this or is it not? So a bit of introspection. But we're also ticking the box so that they're doing an intensive course, perhaps for a fortnight in the field, taking a month in total with pre-reading and post-assessment to get a tick in the box for a tertiary course. So it's essentially an intensive tertiary course delivery instrument or tool based on adventure training and adventurous travel. So I was thinking about, okay, should I, leave ship, leave the university and form my own business to bring those 3 strands together, because it's something that I believe in, that I can give students, a challenging journey. I can give them time to think and reflect upon who they are in the world and how they can best contribute. And I can also give them a tertiary education experience so that they can, still be doing uni by doing these immersive experiences. So I spoke to a few people at USC and beyond. I wasn't quite ready to jump ship. And I spoke to one of our professors and he said, Adrian, great idea, but I don't think we want to lose you. So I think we already have a mechanism by which you can do that at USC. And he was right, we do. It's not exactly along the lines of those model, but it can incorporate most of the facets that I just described. And we have a course, ENS 333, Special Field Studies topic. It's essentially a, what's the word? It's a bracketed course that we keep on the shelf, and we can fit any field-related activity under this course. So it's a shell course. So the beauty is that the administration and the committee approval, etc., for this course exists. So now I can utilize that shell course for any structure that I like. So I'm fortunate that later this year, this image on the left, I'll be taking a 2-week intensive science course teaching glaciology and geomorphology to Mount Cook Village in New Zealand, where we'll spend a couple of weeks walking around the area, looking at the area, discussing the area, evening tutorials and seminars, etc. And they'll have to do some pre-reading before the course, and they'll have to submit a report after the course. But essentially, it will take about a month. They'll tick the course subject box, and they'll get to spend a 2-week immersive experience with me and their colleagues in an inspirational natural environment. So that's running later this year. And for next year, I'm planning a similar trip to Greenland. So I'll be taking science students to Greenland for a couple of weeks. The plan is, again, we'll walk the Arctic Circle Trail. It takes 2 weeks. They'll carry their own food, etc., in their backpacks. Every day, we'll talk about whatever we're seeing, and we'll discuss it in an intellectual context. We'll have further discussions at night. They'll give presentations, etc., etc. And over the course of a month, they will have ticked the box for another elective course at USC in their science degrees. So as I said, I teach in science and engineering, and you can see that I'm rapidly seeking to apply my journeys, my empowering journeys, my immersive journeys of learning to science. And the obvious question we should all ask is, well, can we apply that to engineering? You know, typically we teach engineering in the classroom, we use the labs, they go and do work experience, site visits, etc., etc. But because, at least to myself, I've clearly clearly established to my mind that there is value and a means via which science can be taught in an immersive outdoor education environment. I wonder whether we can also do that in an engineering context. And rather than send our students down for a couple of weeks work experience in Brisbane, can we take them on tours of ancient Rome or ancient Greece? Can we take them to Dubai and look at the construction of, you know, the world's biggest skyscrapers? Can we take them to the United States, say, to do a study of the geology of the Western United States national parks? So I'm essentially about to wrap up here, but this is the question I'm putting out to you. Do you think there's scope within our engineering education, the way we do it, to some extent challenge the convergent, here's some tools, use them to solve a problem, to challenge the convergent way of teaching, and to say, well, I think there's potential for more divergent generation of thought. Should we be taking our students away from these environments to stress them a bit, force them to think a bit more broadly about them, their role, hopefully the positive role with regards to life, society, community, and how might they best, you know, serve the world as an engineer? Potentially by taking them on these immersive expedition-based learning journeys. And that's it. So look, Ivan and you all, thanks very much for your time. Thanks very much for listening. If you're happy, I'll stop sharing my screen, and I'd love to answer any questions or contribute to any discussion or any thoughts that people might have. Thank you again.
Thanks, Adrian, for a very interesting presentation. And I think we have a few questions in the chat. I'm just looking at them. What are they? Where's the chat? Okay. We have a question about those courses. Are they expensive or not? How much are those courses, like those that you will take students somewhere in the field, right? So, and then like probably like spend like 1 month or something with them. So who is paying for those courses? Yeah, I think that's a very good question.
Look, and that is the big question. I'll just tell you a little story again. The reason why my first one is to New Zealand is I have a colleague in England who's a glaciologist. I study with her in the UK, and I met her in Kathmandu. We were both doing some research in the Annapurna Sanctuary about 3 years ago. And I met Rachel there, and I said, hey, Rachel, how are you going? She said, good. I'm actually running a course in New Zealand next year for our undergraduates. And I said, wow, how can you run a course in New Zealand for undergraduates from the UK? And she essentially said it's a user-pays system. So that's what I'm envisaging, that whether it's our domestic students or what I'm thinking is in the post-COVID rebound, if we can offer intensive, immersive, you know, completely different, yet completely engaging courses like this, then the international market is the one that we could potentially tap into, where there's potentially more money there. So for getting the international students, how I envisage domestic students supporting these courses is essentially through the OS Help Loan system. So they can potentially borrow $1,000 or $2,000, tack it onto their HECS. Of course, we have to be very upfront that there will be additional fees for that course. But it's not so expensive. To get to New Zealand, say, we're staying at the youth hostel, we could get a cheap flight return for $500–600. They'd buy their own food for 2 weeks, maybe a couple of $100. So for not much more than $1,000, the students could live with me and maybe another lecturer, maybe 10, 12 students in the youth hostel at Mount Cook. And every day we would have a teaching and learning activity for them to experience that educational environment. There would be a week or two prior when they would do pre-reading and pre-learning so that they come ready to go. And of course, afterwards, there would be time in their home environment, wherever that might be, where they would do a project report, et cetera, and wrap that up. But because it's only about 2 weeks in the field, then it should be manageable through instruments such as OS Help. Greenland will be more expensive, but again, it's just a flight, which might be $1,500 return to Greenland. Once you're there, we're literally backpacking, we're camping. So it's not much more. It's not as if we have to hire a venue. The venue is the world. So similarly, when I talk about engineering, going to Europe, etc., we all know that when international flights resume, you can potentially get a Europe flight for maybe $1,500 return. If we stay in youth hostels, if we backpack, we could spend 2 weeks wandering around ancient ruins of, Greece or Rome, talking about ancient construction techniques, talking about how they might have assessed soil in the past historically. So I don't think the cost is too much, especially when you look at what they're getting out of it, which is, an adventure travel holiday to some extent, an opportunity to immerse themselves in that field for a couple of weeks. And they get a tick in the box. They get a course or subject tick from the university at the end of it after only 2 weeks away and a month of their time. So I'm yet to test this, of course. This is why I'm giving this talk to you today, because I'm intrigued to get your perspectives on whether or not this is or is not viable.
We have something similar at Griffith. We have like one course that we actually run in Cambodia. And I think students go there and spend about 2-3 weeks building like a well or like doing some other activities. So we actually at Griffith we have something similar. We have done it. I'm not sure if we still run it because of the COVID, but that was like one of the courses where we also like take our students overseas, and then like over like 2-3 weeks period of time, they will actually like learn like things like work in teams, develop practical skills and things like that. So maybe if you're interested, we can talk about it later and then maybe like share our experience. We have Graham Jenkins, but he's not with Griffith anymore, but he's been running those courses for some time. And I'm not sure if we'll continue doing that or not, but probably we will.
Yeah, so, I'd love to hear more of that, Ivan. I agree.
Okay, yeah, that's good. And there's a question from Sonia about percentage of your classes that attend, because sometimes, like when we have these interactive classes, like not many like students will turn up, because it's maybe like online or something, and like they will probably like, stay home anyway. But I mean, like, so what is your experience with the attendance of such classes, like flipped lectures, or like, like when you have some kind of like online? Do you still like do online?
Look, I don't believe that large amounts of value can be obtained by purely online learning. So I try not to offer online. I know I briefly looked at Sonia's question there. Yes, many of our students, of course, are working as well. I have families. So it just means I have to be flexible. I'm running field trips next week to the beach. I go out with a doodle poll to all my students and say, what times can you make it? They come back with the times, and then I make my time fit to their requirements. So I make sure that I can ideally accommodate when they can do the time in the field, because I think without face-to-face, without hands-on, then we're losing massive amounts of the learning experience. So I try and manipulate my timetable to address theirs. And looking at one of Sonia's other questions,
about yes. Expensive trip, right?
Yeah, look, I agree with you, Sonia. It's always a concern because most of our students are working. But again, some of them might be quite happy to take leave without pay from work for a 2-week period or whatever it might be, put the money on HEX so they don't have to deal with it until they're working. Their work might or should ideally be supportive of them. I spoke to a lady last night whose company, I think it was Main Roads actually, enabled her to go on a 2-week learning journey to New Zealand, because they knew that the skills that she would learn with regards to leadership, team building, etc., she would bring back to the company and the company would benefit. So depending on the organisation, I think there is a great way there to suggest that if you invest in me by letting me take the time out to do this intensive course, then you will get repayment with regards to that. The cost of equipment, etc. Look, I've been speaking with Outward Bound, who do this for youth in Canberra, and they have a pool of equipment, and they've already suggested if we can lend you equipment to facilitate your courses, then let us know. So I don't expect everyone to go and buy, brand new boots and equipment, whatever. Certainly some expense may be required, but USC runs an outdoor education course as well. They have equipment we can borrow. Outward Bound has equipment. So there are ways to get around that. But, I think that's just the way it is. We need to give our students some challenge and give them, an invitation. And hopefully if they want it, then they will make it work.
Thanks, Adrian. There's a question from Robin. It's about flipped classes. Do you find that many students actually like read before those classes? This is actually like very good questions also for Griffith, if we change to like flipped classes, like if they flip. So will they actually like read like prior to class, or they will just like, do nothing? So what's the experience for that?
Look, that's a great question, Rabin. And I'm teaching Eng 101 at the moment, of course, and I have pre-reading for every tutorial. And I openly acknowledge to them that, no one's going to do that unless there's assessment tied to it, unless I force them to jump through that hoop. So in first year, unless you tie some assessment to it, some marks, I don't think it works. In my third and fourth years, though, when I deliver pre-reading, I don't deliver pre-reading, but I deliver or I state pre-questions for that week. And the expectation is that those students have to find the answers to those questions before the lecture or the seminar. And then in the seminar, I randomly choose a student, and that student then has to come up the front of the classroom and essentially coordinate that seminar and say, okay, the questions for today were X, Y, and Z. Here's my perspective. Here's someone else's perspective. So that forces them to spend at least some time grappling with their own perspectives with regards to that question, because they know they could be put on the spot, essentially running that tutorial or running that session later in the week. So that does seem to work.
Okay, thanks. Actually, Guy has corrected me. We have another course run by Cheryl Dasher. She's from Nathan, she's based in Nathan. So she actually takes her students to Japan, Nagoya, and also like they like learn different skills like this. So this is like one of the courses that we also run here at Griffith, not only Cambodia, but also Japan.
Great. I mean,
yeah.
and
that's forgot about that one. Sorry. Yeah.
No, that's great.
I knew that, but I just forgot to have another course in Japan.
Yeah, that's why it's valuable for me to see that other institutions and people are doing this. It's not it's not necessarily completely novel, but I would love to. I'm yet to have this discussion with my head of school, but I would love to transition out of semester-based normal teaching and just run immersive expedition-based courses around the world, both in science and engineering, because I think as once students get their head around the fact that they could get a complete course done just through 2 weeks to a month and then fit that in with the rest of their life, I think it could be quite attractive. And if we then entertain the international market, I think from a university's perspective, the amount of money that they could bring in by attracting international students, it could be immense. So, I'm still testing the waters a bit at the moment, but I hope that yes, it's quite well established for science, but I hope that we might be able to move into that for engineering as well.
Well, definitely, it's a very good idea to like bring our students somewhere else, and then just give them like more opportunities to learn things by doing like slightly different activities, not just in the class and in the laboratory. So I think it's like really good. Well, it's kind of expensive for some students, probably like not everybody can do it. So is it sort of like an elective course where they can just like select it if they want, right? It's not like must course for everybody, right? So it's like elective. That's right. That's what we have here at Griffith, because we cannot force like everybody to pay like certain amount of money. But if they like would like to have some international experience, go somewhere, like learn different skills, so we actually like offer them these elective courses.
Yeah, and that is the plan, both in science and in engineering. They can do a minor in wider engineering studies. Then we could potentially offer electives in whatever that might be, ancient world engineering or something. and then take them away on that sort of trip. So
Mm.
it appeals again, at least to my mind, across a broad spectrum that might attract a large number of a large amount of interest. Yeah.
There's some comments from Christopher. So how to actually like engage students in these flip classes, like 4 points, right? Or 5 points.
Yeah,
4
thank
points,
you,
right?
Christopher.
So that's from Brahim. So like flipping the classroom. Well, it's always good in theory, but when you try to put it in practice and all these flipped classes, there are always like issues, right? But yeah, definitely there is like good points to follow.
And I think it's at least from my experience, Ivan, it's largely about expectation management. You know, if you spring it on them, then of course there's resistance, and you might retreat back to a normal teaching method. But at least at USC now, all the students know that when they do ENGS 312 and ENGS 432, it will be in a flipped environment. Things will be expected from them immediately, and that information percolates through the the students, of course, and they come in knowing that's how it's going to be. So it tends to work okay.
Thanks, Andrew. Are there any more questions anybody would like to ask? I think we have a few more minutes before we finish.
I just saw you.
Yeah.
And look,
was in the class.
that the overseas trips that I'm talking about, they will be electives, and the maximum number of students would probably be 20 to New Zealand. So we'd probably have 2 lecturers and a group of 20, or maybe just me, but maybe some additional support. ENGS 432, where we build and test a retaining wall, I've had up to 40, perhaps 50 students in that course, and that starts getting a bit too many. So look, I acknowledge that when you run a fairly resource-intensive course involving actual physical constructions, then it can be challenging, especially when we've only got so much lab equipment, etc. It just comes down to scheduling to make sure that every student has the opportunity to do the testing in the lab. And again, I put the ball in their court. I say, look, you're about to be professional engineers. This is when the lab's available. You need to coordinate with the lab technician when you can do that lab. So I stop holding their hand. I hold their hand in year 1 to some extent, but in year 3 and 4, I say, right, you're big people. Time for you to take control and manage your course. You tell me how you're going to make that happen.
Okay. Well, thanks, Andrew. And I think we'll have to conclude this this seminar. I just want to thank you again for your time for this interesting presentation. There are many interesting ideas from your talk about understanding and doing and things like that, about taking students somewhere else. Definitely like something for us to learn. And maybe, well, if you're interested about our experience, I will be happy to share it with you about our international courses. So we can probably talk about it after the seminar. So, but I think we need to finish by 1 p.m. I don't know what is going to happen to the link. Maybe it will just like stop by itself. So I just want to thank you. Well, and hopefully you will join our like following seminars. So we have it like every month. So if you can share it with your colleagues, that will be really great, so that I would like to bring as many participants and speakers as possible, so that we can share our good practices for them and learn from like people like you. Well, thanks again. And I think we'll just probably stop recording and conclude the session.
Great, thanks, Ivan, and thank you everyone for attending. I appreciate your feedback. It's all very helpful.
Yeah, thanks.
Thanks,
everybody, and thanks for attending the session. We have another one in April. Please check our website. I will send you reminders about next presentation. And if you can share with your colleagues or other units, other countries, that would be great. And thanks, and have a nice day. Bye.
Thanks, Ivan.